So welcome all. Remember that we were in our previous class, again, like a quick recall. What we have learned is we learned about indifference curves, right? So apparently we had a utility function, right? So if we have, for instance, two goods, utility function is actually of which dimension? So the utility function, if I have two goods, right? So I have a utility function like this. So this is going, right? So it's basically, remember we talked about putting a dome in this classroom and whatever. So it's basically you have an amount of X, you have an amount of Y, and then, you know, they're going to give you a number, right? Somewhere in this classroom, right? So that is what we mean by like when we have two goods by a utility function. So then we said that, well, this is a three-dimensional object, so maybe we can actually just cut this, you know, like dome, for instance, in this classroom at certain utility levels, and then we can take the projection on the XY plane, right? And how did we call those curves? So they were called what? So we put here quantity of X, we put here quantity of Y. And if we put those, you know, like what we call the level curves, right? We called them, they had a special name in the utility, right? So they were called? No, they were called, these level curves were called indifference curves, right? So we said that they were giving these, so whatever you say is correct, but that's, you're saying that, oh, hocam, utility function should be, you know, like at least quasi-concave, strictly quasi-concave to have strictly convex indifference curves, okay? But we will come to that. But we said that, and this indifference curve, so this was kind of, you know, the mathematical meaning, but this also had an economic meaning as well, right? So there is some sort of an economic intuition. So we said that, oh, we asked the consumer to tell us which bundles you're indifferent to, right? So like, and let's say you have a bundle here, X star, Y star. So we ask the consumer, can you tell us all the other bundles to which you're indifferent to X star, Y star, right? So then actually consumer told us, so basically all these bundles were giving us the same utility, right? So that's what we said. And then this was indifference curve. And then we actually said that, well, there might be, so we talked about some properties of preferences, but basically we said that we could have actually more assumptions about tastes, right? So one of them was, remember, one was more is better. So we actually said that, right, so more is better. We said that this might not be realistic all the time, but this is one of the assumptions that we will be making, okay, most of the time. And then there was another one. What was it? So we said that if you look at these indifference curves, they look like what? We said that they are, right, strictly convex, right? So basically we said one is more is better and the other one is basically strict convexity of indifference curves. Okay? So these properties, they don't have to be satisfied, okay? So these are extra properties. If they are there, we know what they correspond to, okay? So like in terms of math, so we'll see. So this is the strict convexity of indifference curves. Then we said that strictly convex, meaning that actually we have these nicely shaped indifference curves, right? But we said that, well, we're talking about this indifference curve here. But what about, so if we have these convexity of indifference curves, what does this tell about our utility function, right? So what does it mean that if the indifference curves are strictly convex, then, you know, like the utility function, for instance, which is like a dome here, or which is like a cone here, right? Or which is like what we said, a pinched cone, right here, is what? We said it should be, to get these nicely shaped indifference curves, remember I wrote 4 things, right? So what were they? So this is actually, this is about indifference curves, right? If I want, and remember that is the level curve of this utility function, right? So that was one thing. So you said that if I need to tell this to my grandma, one thing that I would say is that strict convexity of indifference curve, there is something that we observed here, right? The marginal rate of substitution was diminishing along this indifference curve, right, as x increases. So one thing was that, so we said that diminishing marginal rate of substitution is actually equivalent to, remember we did all of this, so the first thing that we said, at least as good as sets are convex, okay, that's what we said. And then what else we said? We said strict convexity of indifference curves. Right? So what does that strict mean? Remember about this indifference curve. Suppose I had an indifference curve like this. So I had y, x. So I had an indifference curve like this. Do you think this is strictly convex? So let's look at the marginal rate of substitutions, for instance, right? So here it's diminishing, right? What about here? What's happening here? It doesn't change, right? It's flat. So don't forget that. Remember, strict, if there is this, you know, like if it says strictly convex, it means that you don't have flat portions, right? It's just, for instance, this curve is also convex. It's linear, but it's also convex, right? But it's not strictly convex, okay? So if it's strictly convex, that you don't have flat portions, okay? So this is basically, so that's what we said. And then this was the last thing that we were considering. So if the level curve, right, so this indifference curve is strictly convex, it means that the utility function which gives this curve is, right, so you said it's strictly at least strictly quasi-concave. Okay, so that's actually what we said. So this was basically at least strictly quasi-concave utility function.
Can you explain this?
So this is actually, so remember we said that, so basically, so here, remember what we said is that we want, if we would like to have those nicely shaped indifference curves, then we should have a utility function, apparently at least strictly quasi-concave, right? And then remember we gave the definition and such, but what is important, those are just, you know, like the formal definition, but remember what is important for this course is that you understand that this strict convexity, what does it mean, right? If you need to explain it to your grandma, what does it mean? So there is one thing that you can say is that, oh, it means that there is diminishing marginal rate of substitution, right? What did that mean? Remember, as I have more beer or Coke, right, the amount of chips that I'm willing to give up to have one more unit of Coke keeps decreasing, right? So basically, so that's what we mean by diminishing marginal rate of substitution. And then we were actually, so this was the end of last class. Remember, we were trying to give, actually, we tried to give another explanation, which is also something that you can tell your grandma, right? So what do we mean by strict convexity of indifference curves? So it basically means this. Suppose this is, you know, like we have U, and suppose, I think this is what we did, right? So suppose we have x1, y1, and suppose we have x2, y2. I'm sorry, so, right? So this is what we said, right? So this was actually the example, okay? Now, then, basically, if this indifference curve it has this nice shape, it means that, so when I'm taking the convex combination of these guys, suppose I take the midpoint, right? So, and you can think of it like this. Suppose you have 2 bottles of, let's say, like 2 cans of Coke, and you have, let's say, 20 slices of pizza, okay? And suppose you have here 20 bottles of Coke and 2 slices of pizza, okay? So what strict convexity means is that suppose I have 2 plus 20 divided by 2. What is this? 11, right? So suppose I have 11, basically. Remember, I told you to think about this. And suppose here I also have, y1 plus y2 divided by 2. And this is going to be x1 plus x2 divided by 2, okay? So basically, suppose I take the midpoint, right? So this midpoint actually lies here, right? So you see that if I have a more balanced bundle, which has more, like Coke and more pizza, right? If I have a more balanced bundle, then is it on a higher indifference curve or a lower indifference curve? Higher, right? So this is going to give you more utility. So this is another explanation that you can actually explain, that you can tell your grandma, that this strict convexity of indifference curves, it means that you prefer, right, let's say, you prefer having 11 Cokes and 11, slices of pizza to having 20 cans of Coke, right, 20 Cokes and 2 slices of pizza, right? You prefer more balanced bundles instead of bundles which are heavily weighted towards one commodity, okay? So this is also, you see that these are all math concepts, but we can always link them to, what we kind of think, which is making a lot of sense, right? So basically, that's probably what you would say. What am I going to do with 20 slices of pizza if I only have 1 can of Coke, right? Or like 1 glass of Coke. Or what am I going to do with 20 cans of Coke if I only have 1 slice of pizza, right? So basically, you prefer bundles which are actually more balanced, okay? So let me write this down. And this is not only true for the midpoint, right? So we put it like this. You see that all the convex combinations of these guys, these 2 points, all the convex combinations lie on this line, right? And then you see that they are all on a higher, they would be, we don't know, maybe this is on this indifference curve, maybe this guy is on this indifference curve, but what matters is that all of them are actually on a higher indifference curve, okay? So basically, this is actually the case. So let me actually write this down. The combination, or let's put it like this, all convex combinations, okay? So I think it's better. So all convex combinations okay, all convex combinations are preferred to both x1, y1 and x2, y2, okay? So all the convex combinations are preferred to these bundles. That's what strict convexity means. And what does that mean? Again, this is a little bit too math for your grandma. So you can actually say that this means, so well-balanced bundles of commodities, okay, are preferred to bundles that are heavily weighted towards one commodity. Okay? So basically, or you can easily say that individuals prefer well-balanced bundles, right? So they don't prefer, basically individuals prefer some sort of a balance. in their consumption. But remember, we said that these are extra assumptions. It could be, you know, like you could be some sort of a different person, and your tastes, right, might not, or your preferences might not have these properties. You might be like, no, I like one bottle of Coke and 20 slices of pizza more than, you know, like a balanced one. Okay, maybe you like one commodity, right, much more than the other, right?
But still, I don't understand how we reconnect convex or diminishing marginal rate of substitution with at least strictly quasi-concave.
So this is basically if you look at, you know, like the condition. So if you have, you know, like you don't understand the at least part, or you don't understand the quasi-concavity.
How we can connect quasi-concave utility functions with diminishing marginal rate of substitution?
It's actually through, so if you have a strictly quasi-concave utility function, then it's for sure that you would have strictly convex indifference curves, okay? And remember, if you have strictly convex indifference curves, then you would have an indifference curve like this. And on this indifference curve, you can actually see that there is diminishing marginal rate of substitution, okay? So we can show all of them like formally, but for the time being, just know the links, okay? That's it.
Convexity is equal to strictly quasi-concave.
So these expressions are equivalent, okay? So if I have this, then I have this. If I have this, then I have this, okay? So these are all equal statements, okay? That's why I put like these signs of both ways, okay? So that's why I put here at least strictly quasi-concave, because if it's concave, it would also work as well, okay? If it's concave, then it's going to work as well, okay? Remember, if it's concave, it's quasi-concave, right? But the reverse is not correct, right? Yes.
Can we say the reverse version? Then, I mean, strictly concave curves are also strictly quasi-convex.
But remember, these are not the whatever. So here, the concavity is about the utility function. Here, convexity is about the indifference curve of that utility function, okay? So if, you know, like, let's make it clear. So we're trying to say the same thing, but for different objects, right? One here is the utility function. Then I try to get its level curve, and I try to say something about its level curve, right? Which we say it's convex. Okay? So these are different functions actually. Here you have the utility function. Here we're talking about the indifference curve. Okay? So is that clear? Good. Now remember, we gave the definition, but don't worry about it for the you know, like for this course. All I want you to know is that what those, you know, like mathematical concepts mean, okay? So if you need to tell it to your grandma, what do they mean, okay? So that's it. I will never ask you to memorize that definition or, you know, like, or to use it, okay? But at least have some idea and, you know, like, and mean, just, you know, like, be aware what it means, okay? What is the link between the shape of this guy and what do we call the shape of this guy? We say, oh, strictly convex. And how is it related to the concept of marginal rate of substitution? Apparently, it's related to the concept of marginal rate of substitution like this, right? It's like marginal rate of substitution is diminishing, then I have actually strictly convex indifference curves, okay? So all these links between these concepts. So all you need to know is this. Now let's actually solve an example. So you'll see that things will be much easier, you know, like when we start working with examples. So suppose, let's say that, you know, like that's what we were saying. Let's say Harun consumes only, you know, like beer and chips. And then suppose, then we said that, you know, like his X is, let's say, R2 plus, right? Because we have two goods. And then suppose Harun's ranking of bundles of beer and chips can be represented via this utility function, okay? So this is basically x to the power 1 over 4, y to the power 1 over 4, okay? Now you'll see things much better. So suppose this is it. So if I want to get, for instance, Harun's indifference curve let's say for utility level, let's say u bar 5. How, if someone asks you to draw his indifference curve when utility level is at 5, or at any given utility level, what would you do? You're just going to set this utility function, right? So basically equal to 5. And you would try to draw this, right? If you want to draw it, remember we were drawing the indifference curve. So then you can get y equals to, as a function of x, and you would try to draw this, right? So basically you see that this is indifference curve of Harun, okay, at utility level 5. Or this could have been, instead of 5, I could have said u0, right? So whatever, or u bar. So then you would say that you would set it equal to u bar, and then you're going to say that at utility level u bar, okay? But this is the idea. It could be at any given number, okay? So let's keep 5. So let's have 5. Now, how am I going to draw this? So, I can, but this is not, this is not very easy to draw, right? Can you draw me this, if I tell you just draw me this, the relationship between x and y, right? Draw me this indifference curve. You might say that, oh, hocam, you'll try to find points and such, but it doesn't seem very, immediate, right? Drawing this. What do you think we can do?
To the power of 4.
So the first thing that you think of, okay, raise it to the power, right, 4. But then, but what guarantees that we could do that? Remember, we said something that's why we covered all those, blah, 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 blah. But actually, there was a reason. Why do you think we can raise it to power 4?
Number of bundles are Thompson.
No. It doesn't. You see, this is R2 plus. So your friend is right. Actually, sometimes whenever we talk about, when I tell you goods, sometimes these goods are not divisible, right? So you cannot divide a can of Coke. But I can think of it as liters of Coke, right? So it could be more continuous. But he's right, But let's forget about that. Suppose everything is divisible, we measure them in liters and whatever. So that I can have very, even, I can have decimals and such, okay? They don't have to be integers. But he's right. But what else? Remember, what did we say? If I raise this to the power 4, do you think the utility, suppose, if I say, let's say this bundle utility of xy, suppose one thing gives, let's say 40, or let's say 4, and the other one, utility, let's say x1, y1 gives this, okay? Utility x2, y2 gives 5. So if I raise this utility function to the power 4, then this bundle is going to give me how much utility? If it's raised to the power 4, suppose let's call this u tilde, x1, y1. Right? To the power 4, right? So 4 to the power 4. What will this give? Doesn't matter. 5 to the power 4, right? Then? So, right? Exactly. Remember, the important thing was the order. So if I raise it to power 4, did it change? Did the fact change that I like this guy, this bundle, more than this, right? It gives me more utility. So this gives 5, and this gives 4. Now I raised it to the power 4, right? So this gives what? 625, right? 625. And what about this? 256, right? So then the fact that I like this guy more than this guy, did it change? It didn't change, right? Okay, so but suppose you know what we call this? We call this the fact that you could raise it to power 4. It's actually, we say you're taking a positive monotone transformation, okay? Suppose I take, like if I take square, that would also be the case. Suppose I take it, but what about, for instance, suppose I take this instead of, taking to the power 4. Suppose I actually have this. My u tilde is actually doing, takes this u, right? But actually gives minus uxy. Do you think now what would change? Remember, suppose you have this. You have this guy. It says that when I take this transformation, it takes this guy and gives, but minus 4, right? It takes this guy and gives minus 5, right? Then, right, is it still the same? So which one is better now? Minus 4 is better, right? Because it's a bigger number, right? You see that if I take this transformation, so I cannot take minus of it, right? So basically this is called, because this is not a positive monotone transformation, it's going to be a negative monotone transformation, okay? So it's going to switch the order. So what we allow is not this guy, but what we allow is actually these kind of transformations, okay? And now, as you suggested, let's do this. So you said that, hocam, it's very hard to deal with that curve. So we're going to take another utility function, right? Which is going to be, we're going to take u of xy to the power 4, okay? This is a positive monotone transformation, which is allowed. And basically, so this is going to be what? If I do that, it's going to be x to the xy, right? And then this is going to be, right, 625. So then what is this? So 625 xy. So is this easier to draw? Right? So apparently there was an indifference curve. We set it to the level equals to 5, right? Utility level. Here we took everything to the power 4, so it's now equal to the utility level 625. But we know that it represents the same information. Okay? So is it possible for me to draw this? Yes. So it's much easier. This is actually called, that this is called a rectangular hyperbola, but don't worry about it. So, but this is much easier to draw, right? So let me draw this. So basically, what does this say? It says that in this one, for instance, x star, y star was giving a utility level 5. Now in this one, x star, y star is giving a utility level 625. But I know, right, the order would be preserved. So I put here x, I put here y. So I can actually draw this, right? So it's going to have this form. So let me plot some points on this. So this is going to be 5. This is going to be 125. And then this is going to be 125. And this is going to be 5. And then let's say we know that, for instance, 25, 25 is also here. Is it the midpoint though? That's what I asked in the previous lecture, right? We know that the midpoint is, somewhere up, right? So basically, of course, this is not very much to the scale, but the midpoint between 5 and 25 is like 65. It's somewhere here, right? And it's like 65. It's somewhere here. Okay? So it's somewhere here. We know that, remember, the convex combination, all the convex combinations were actually giving a higher utility level, right? So this is basically the case, fine. So let me try to compute, for instance, let me try to compute, for instance, marginal rate of substitution. So marginal rate of substitution at, okay, so let's have 125. What is this? So if I want to calculate the marginal rate of substitution, what should I do? Remember, how did we define marginal rate of substitution? Right, so we said that marginal rate of substitution is minus dy over dx, and when you keep the utility level the same, right? But we said that u is equal to 5 or u tilde is equal to 625, right? So we know that it would be, the order would be preserved in both cases, right? So now this could be the case. So in order to do this, what should I do? I should take the derivative of this guy with respect to x, right? What is it? So if you look at MRS here, so what's the derivative of this guy with respect to x? Minus, right? 625 divided by x squared, right? And there's another minus because of the definition, right? So then you see that MRS is 625 divided by x squared, okay? So let's try to find this. So marginal rate of substitution at 125 is what? You said that hocam 625 divided by, what is it? What is my x? It's 5, right? So it's 25. So this is going to be 25. So what does this mean? It means that, remember what marginal rate of substitution meant. It means that if I want to have one more x, of course, in this neighborhood, so it's the slope. So if I want to have a little bit more of x, like one more x, let's say, I'm willing to give up 25 y's, right? If I want to have one more Coke, I'm willing to give up 25 slices of pizza. Why? Because I only have 5 Cokes and I have 125 pizzas, right? So definitely I would be willing to give up lots of pizzas. But what about here? Do you expect the marginal rate of substitution to fall or to increase? To fall, right? Obviously. You see that whatever we said conceptually, we can also show it via math, right? So marginal rate of substitution at 125, 25, 625 divided by 125 squared, right? So what is this? It's 1 over 25, right? So 0.04. Then what is this? It means that if I'm here, because I already have lots of Coke, in order to have one more Coke, I'm willing to give up very little pizza, right? Like 0.04 slices of pizza, okay? So you see that you can always interpret these numbers. They have a meaning, right? They're not just numbers, okay? So this is basically the case. So clearly, so here what we could see is that, or you can actually see it through here too, right? As x increases, marginal rate of substitution, as x increases, I have more, like drinks, then the amount of pizzas I'm willing to give up will decrease, right? So marginal rate of substitution will decrease. Okay, so you see that we can actually show all of this via math. Now, let's also see this. So what about, so if I actually look at, so let me put it like this because it should be right here. So I can actually have this here. So if you see that if you don't draw things properly, then like you might have a bit of a problem, right? So it's actually, so suppose it's here. Now how can I show that these indifference curves are strictly convex? You can say that hocam marginal rate of substitution is diminishing, right? So you can say it immediately. That also, you can actually say that that's enough, but you can also, like elaborate even further, and then you can actually say that hocam, if these indifference curves are strictly convex, then I know that this strict, this actually, for instance, this midpoint should be giving more utility or less utility. More, right? So let's see whether that is actually the case. So let's check. So what about the utility at that point, right? So suppose we know that utility of, so we can actually say this. utility of xy is x to the power 1 over 4, y to the power 1 over 4, right? Utility, for instance, and then we know that these other guys, so let's say utility of 65, 65, right? So this is going to be 65 to the power 1 over 4, 65 to the power 1 over 4, right? So this becomes 65 to the power 1 over 2. And we know that 64 is, you know, the square of 8. So this is a little bit larger than 8, right? So that's what we actually know. So it's around this number, right? But we know that all these bundles, right? For instance, x1, x2, right? These guys, like 5, 125 or 125, 5, they were all giving utility level 5, right? So you see that obviously u of, so let's put it 5, 125, utility 125, 5, which is equal to, right? We said 5, right? So you see that the midpoint is actually providing more utility. But of course, if you need to check, you have to check all the convex combinations. And all the convex combinations of this guy and this guy would yield more utility. Okay, this is what you would find. So you see that all these stuff that we talked about, actually you can check, right? So, but it's not, don't forget that, so let me write it like this. So basically, this is another way of looking at it, but you should look at all convex combinations. Okay, not only midpoint. Okay, but you should check. So basically, or check whether midpoint gives more utility or not. Okay, so for instance, you can check, but we said that it's not enough to check only midpoint, right? But you should actually check all the convex combinations. So most of the time we don't check this, but we show that it's actually the marginal rate of substitution is diminishing. Okay. Now let's give a break, and then we'll actually continue in the second hour. Mm-hmm.